So welcome students once again. Today we will discuss about pulley. We all have seen pulley, generally mostly used by the people in the village side. So what is pulley? Pulley is nothing but one kind of a simple machine and which is associated to wheel and axle category. So this pulley are of two types. One is single fixed pulley and one is single movable pulley. So first of all, we will discuss about single fixed pulley. Now, why this is single? Now, since here only one circular disc is used and only one rope, one single string or rope is used. So that's why it is called single. Why fixed? So to know why is it called fixed, first of all we need to know its construction. Generally, it is a kind of metallic circular disc whose one side is fixed at the upper side, rigid support, and this metallic circular disc is generally passed through a metallic rectangular frame. This is generally, most of the time it is generally made up of iron. This is called the frame, which is made up of iron, and this is called the axle, which is generally fixed, generally used by a nail. Generally a nail is used. Now this is the front view. This is the front view of the axle and frame and the axle. But here you can see this is the wide view of the frame along with axle. Generally it is a three-sided, isn't it? Just like the goal post, isn't it? This side is open, and generally a three-sided, a frame you can see there is a rectangular but this side is open. So this is a three-sided frame, and these two sides are generally attached, fixed by applying a nail. So this is generally fixed, two sides. So generally nail is used, is attached, and these two sides are fixed. And in between this gap, this circular disc is generally passed. Clear? And through the circular disc, a rope or string is generally passed over it, whose one side load is suspended and which is lifted up by applying the effort towards the other side. Now why it is fixed? Now since the metallic disc rotates, when we apply force towards the rope, towards the effort side, towards the side or rope of the effort side, now due to the friction between the rope and the metallic disc, this disc rotates, and due to this rotation load is lifted up. Okay, now this string has to be inextensible and massless. Okay, inextensible mass has to be negligible. Clear? Why inextensible? Now since we have seen that when we apply force towards the effort end, due to the friction between the rope and the circular disc, this disc rotates and the load is lifted up. But if the rope is not inextensible, it means if it is extensible, it means if it possesses some elastic property, it means it is stretchable, then in spite of, without of any kind of rotation of the disc, metallic disc, the load will lift up. Clear? So obviously it will be an error, and the string has to be massless, otherwise its mass will be added to its its efficiency or its working calculation. So this is single fixed pulley. So a single fixed pulley is generally made up of a circular metallic disc. Generally some of the parts generally grooved. Okay, some of the parts are grooved. Clear? Some hinge or gap is generally placed, and which is generally rotate about a frame, which is generally fixed by a nail, which is called axle. And this axis of rotation, since is rotation, this is this axis. So you can see, since this part is generally fixed with a hook to a rigid support, so it cannot move. This is fixed, only wheel is rotated. So that's why it is called single fixed pulley. So now we will calculate its mechanical advantage, velocity ratio, and efficiency, all these quantities. So you can see towards the left side load is suspended, and towards the right side effort is applied, and due to application of the by applying the force, load is lifted up. So on the two sides, since here string or rope is used, so obviously two sides tension will act, so both tension will act in the upward direction. Towards right side in single effort and single load. So towards the left side, this tension will be supported by the load, and towards this side tension will be supported by the effort. So we can see L equals to E equals to T, since both load and effort are supported by the single tension each. Now mechanical advantage, we all know that mechanical advantage is equal to load by effort, so T by T equals to 1. So here it is mechanical advantage equals to 1. So what does it mean? Here mechanical advantage is neither greater than nor less than 1. If mechanical advantage is greater than 1, it means it, in that case the device acts as a force multiplier, and if it is less than 1, it would act as a speed multiplier. So it is neither force multiplier nor speed multiplier, it is equals to 1. So we have already seen, okay, we have already learned during discussion of the initial portion of the machine chapter, that is when the mechanical advantage of a machine, of a simple machine is 1, it means it acts neither as a force multiplier nor as a speed multiplier. It can only use as, okay, it can be used only to apply the effort in the convenient direction according to our, okay, according to our own desire. Okay, now it's velocity ratio. Velocity ratio is nothing but the ratio between the distance traveled by the effort side by load side. Now here x by x means both. We could use d by d or y by y. It means the distance traversed by both effort side and the load side, or the string or the portion. Okay, that is the load arm, effort arm and the load arm are same. Why? It is very easy. Now since load is lifted up only due to applying effort in the downward direction, it means load cannot be lifted up without applying the force in the effort side. So it means if we apply force, suppose if we apply force towards the effort end, it means then if the effort arm, that is the string towards the effort end, if it travels or if it moves 10 meter, so obviously that string towards the load side obviously will travel the same distance, that is 10 meters. So that's why distance are same, that is equal to 1. Now what will be the efficiency of this kind of pulley? So mechanical advantage divided by velocity ratio into 100% equals to either 1 or 100%. Clear? So this is the single fixed pulley. Clear? Now what is the use? It is neither force multiplier nor speed multiplier equals to 1. Then why single fixed pulley is used? Single fixed pulley is generally used to lift up small load, isn't it? Just like bucket of water from well, most of the time. Okay, but since it is used, why? Now you can see here effort is applying in the, here effort is applied in the downward direction. It means towards the gravity. We all know that whenever we apply any force against gravity, it is very hard working, isn't it? It is quite painful. We, in that case, we need to apply, we need to waste more energy. But when we apply any force towards the gravity, it becomes very handy, isn't it? Very easy. So since here gravity is pulling each and every object towards its own center, towards its side, so weight is acting in the downward direction and we are applying the force, okay, in the same direction. So in this case it is not at all so much, isn't it, so much oppressive, isn't it? Okay, so it means in that case only the single fixed pulley is only used to do work, okay, to do our work only by applying force, only by changing the direction of the force in the convenient direction. Here what is the convenient direction? Here the convenient direction is towards the gravity, that is the downward direction. Clear? So this is single fixed pulley. Okay, now moves on to single movable pulley. In single movable pulley, unlike single fixed pulley, its axis of rotation is not fixed. You can see from the diagram. Okay, this is the circular metallic disc, okay, whose one side you can see obviously. Also it possesses two section or two section of the rope. One portion of the rope is fixed to a rigid support, or the other side effort is applied, but unlike single fixed pulley, here effort is applied in the upward direction, that is against gravity. This side is free, you can see. In the previous case the axis of rotation was fixed, but since it was attached to a rigid support, but here this is open, and with this axis of rotation load is suspended, okay, and effort is applied in the upward direction, and due to application of the force in the upward direction, load is generally moved in the upward direction along with the circular disc, which is passed over this like this, which is shown by the dotted line. If we apply any force in the effort side, then it will just move the entire disc along with its axis of rotation, and it will just grab in this position, isn't it? Just imagine like this, it will take in this position. After some time load will be in this position, then we can easily take the load in this case. So here in the same cases, here is obviously the rope has two sections, one side effort, but here load is not acting on the other side, unlike single fixed pulley. Clear? Load, instead of that, here load is suspended at the middle. So it means both sides, it is supported by the tension of the both sides. So it means tensions of the both segment of the ropes contributes to lift up the load. Clear? See here effort equals to T. Why? Since effort is acting only at the one side. So only tension of that side will be supported by the effort. So here effort is equal to T. But here load is equal to the addition, the sum of the two tension. Why? Since here load is acting in the middle portion. So tension of this string and tension of this string both contributes equally to lift up the load. So that's why, since the load is supported by the tension of the both sides, so that's why load is equal to twice T. So mechanical advantage is equal to load by effort is equal to twice T by T. That is 2. It means it is multiplied. It is greater than 1. So obviously we can say it is a force multiplier. Okay. Then velocity ratio, distance effort by effort and distance effort by load. Now here distance effort by the distance traveled by effort is twice the distance traveled by load. Why? Think very minutely. Okay. Now generally in this case load is generally lifted up by applying effort in this direction. Okay. So it means if we pull the effort, okay, if we apply force in the, because we have to apply force in the upward direction in this case. So suppose we are pulling, okay, we are applying some force in this direction. So since this side is not fixed, this is movable. So obviously this sector, isn't it? This arc and this arc. Okay. So when it will pull, this side will also move some direction along with this. This side will also traverse some distance and this side will also traverse same distance. Since it is supported, it is attached with the both portion. So if we apply the load, okay, so if we lift up the load, suppose we have moved the load through x distance, through distance x. Now if load moves through x distance from this side, so automatically this sides also move in the upward direction, lift up, isn't it? If we okay, if suppose, isn't it? Now we are applying, okay, we are applying some force. Okay, we have applied some force at the effort side to lift up the load. So suppose this portion, since it will just move in the upward direction, so this side will move x. So automatically, since these two sides are attached with the load with this portion, so this side will move automatically along with this side. These sides cannot be fixed. It will also traverse same distance. So x plus x. So this x plus s, okay, will make effect, will make influence in the effort side. If load is traversed by x distance, this side will automatically traverse by x distance, and both this x portion, this x distance and this x distance will be added, and totally the string at the effort end will just moves twice x distance. I think it is clear, isn't it? Because it cannot happen that if load moves to x distance in this portion cannot move. You can see obvious, this portion and this portion automatically move. So x plus x automatically twice x, isn't it? This will be the simultaneous effort. So that is 2. So that's why our mechanical advantage is equal to 2. What is the velocity ratio? Velocity ratio is 2 because the distance traversed by the effort is twice than the distance effort by the traveled by the load. So this is 2. What is efficiency? Efficiency is always 100%, but it is only in case of ideal machine. Since it is not possible, you can see both in case of efficiency of the single fixed pulley and single movable pulley. If according to calculation it is 1 or 100%, but since we have already learned that it is not possible for any practical machine, okay, to possess 100% efficiency, because there will be some friction between the rope and the circular metallic disc. There will be some friction between this axle and frame. So due to this, output energy will be less than input energy. This is only possible in case of ideal machine. Clear? So now in this case, which we need to discuss now, which is worth to discuss. In previous case, we saw that effort was acting in the downward direction. Here effort is acting in the upward direction. We always know that to apply force, anything which is acting towards the gravity is much easier, whereas anything to lift against gravity is quite painful, is quite oppressive. But in spite of that, in spite of applying effort against gravity, here mechanical advantage is 2. It means output is, isn't it? To lift up some load, we need to apply less force. Why is it so? Isn't it? It means it acts as a force multiplier, because that force is multiplied. Effort was T, load means output, effort is the input, load is the output. So output is double. So that's why it is force multiplied, force is multiplied at the output. But here effort is applied in the upward direction, in the against gravity. But in spite of applying force in the downward direction towards gravity, its mechanical advantage, it is not acting, its mechanical advantage is not greater than 1, means it is not acting as a force multiplier, but it is, as I saw, okay, as I have already told, okay, since it is only used to change the direction of effort in the convenient direction. Okay, by applying force you can see, yes, to apply force in this direction is quite painful, towards this side is quite painful, but to apply force in the downward direction is much easier, so that's why it is used. But why instead of applying effort in the upward direction, that is against gravity, here we need to apply less force to lift up a huge load? For that you need to focus on this expression. We all know that work done equals to force into displacement. Clear? Work done equals to force into displacement. Now here you can see, here the distance travelled by the effort part is twice the distance travelled by the load. Clear? That is the twice distance. Now suppose work done is 20 joule. Clear? Now at the first case, the force was applied was 2 Newton to move the rope or anything up to distance 10 meter. If the same object is moved up to, if we to move the twice distance, you can see force is generally halved, isn't it? 20 joule, force was 2 Newton. Okay, suppose you are pushing the object, you are displacing some object up to 10 meter, so here the required force is 2 Newton. Now suppose you are not interested to apply more force, then in that case, if you just increase double the distance, in that case force will be halved. You can see it is also 20 joule. So it means in case of traveling greater distance, force will be halved, isn't it? You don't need to apply more force. If you increase the distance, according to relation work done equals to force into distance. If we increase the force, distance will be less. To get same amount of work done is fixed 20. But if you want to travel more distance, in that case we don't need to apply more force. Only it is enough to apply less force. Same thing is happening here. Clear? Why? Yeah, here you can see, here effort is traveling, the effort side is traveling twice distance, isn't it? X plus x is equal to twice x. Since the effort side, since the segment of the rope of the effort part is traveling more distance than that of load, that is twice x, so that's why in this case force is less. Clear? So that's why it is acting as a force multiplier. Since the effort end moves at a greater distance, so in that case, since distance is greater, so here applied force is less, so that's why it is force multiplier. Clear? And so this is the single movable pulley and single fixed pulley. Clear? Now what are the differences? Very easy. A single fixed pulley, axis of rotation is fixed, whereas the single movable pulley, axis of rotation is not fixed, but rather it is movable. Clear? Its mechanical advantage is equals to 1, its mechanical advantage is equals to 2, its velocity is equal to 1, its velocity is equals to 2. It acts neither as a force multiplier nor speed multiplier. Rather than it is used to change the direction of the effort only in the concurrent direction, whereas it is used as a force multiplier. It is generally used to lift up small loads like a bucket of water from well, but this has a wide range of applications. It is generally used in case of crane to lift up heavy loads. In industry, generally crane is used, isn't it? Generally inside crane, this type of pulley is generally used. In so many in gym center to lift up the huge loads, generally this type of pulley is used. Clear?